Okay, very warm welcome everyone to this PROTEUS seminar series. Today, our speaker is Robin Poidevin. He's a professor in Leeds, at the University of Leeds, and he will talk today about space-time detachment arguments and two kinds of determinism. Thank you very much for being here today.
Fantastic. Thank you very much, Sylvia, and thank you very much for the invitation. I'm really pleased to be invited to be part of this seminar series. Okay, now Sylvia told me that I would have a mixed audience this afternoon in the sense that there'll be philosophers present, but also physicists as well, which of course presents its own kind of challenge. So I should explain, I'm a philosopher, and the talk I'm going to be giving today, I think probably could be characterized as a sort of metaphysics of space and time, as opposed to philosophy of space-time physics, although, as you know, the boundary between those two things can get a little bit blurred. But I have aimed for what I hope is sort of accessibility without a lot of sort of technical philosophical jargon, and the consequence of that is much of what I say may be already familiar to philosophers, but I hope not all of what I say will be familiar. I hope there will be something a little bit new. Equally, I hope I shan't make any appalling scientific blunder, but if I do, you're welcome to point that out. I should be suitably chastised. So here we go then. Here's the structure of the talk, so you can see where we are at any point, and also how close you are to the end of the talk, which is always sometimes good to know. So first of all, I'm going to say a few words about a really important debate on the nature of space and time, or space-time, namely the debate between relationism on the one hand and substantivalism or absolutism on the other. This is a debate concerning the relationship between space-time and its contents, such as material objects or force fields. Then I'm going to sort of plunge back into history to discuss a couple of famous arguments by Leibniz against absolutism stroke substantivalism and in favor of his own relationist view of space and time. Having presented those, I'm just going to ask a little bit about what a detachment argument is. And then we'll just have a little interlude where we talk about Henri Poincaré's famous thought experiment, where everything increases in size overnight, which is like Leibniz's arguments, intended as an objection to substantivalism about space. But I'm going to suggest it's not precisely similar. It's not a detachment argument in the same sense. Then back to Leibniz again, and I'm going to ask a question that was raised by Graham Nerlich about whether it makes a difference to Leibniz's arguments that he's assuming that space is Euclidean, that it's flat. What happens to detachment arguments when you introduce the possibility of non-Euclidean space not being flat but having some sort of curvature? And then finally, I'm going to look at a connection that I think I've discerned between detachment arguments on the one hand and determinism on the other. I'm going to define two kinds of determinism. One I think we should care about, the other I think is distinctly odd, a little bit perhaps dodgy. So that's the talk. So let's get straight into the debate I want to focus on. So we start with a kind of large and rather intimidating question: what is space-time? Just a point about terminology here. When I'm talking about space-time, I'm not necessarily alluding to relativistic space-time or kind of a view in which space and time are somehow kind of linked together. So I'm using space-time here as a neutral word, which could cover classical space-times, where we think of space and time as separate entities. So one way of focusing the question, what is space-time, which is rather a large question, is to ask, does space-time exist, or can it exist independently of its contents, independently, e.g. of material objects or force fields? So two answers to that question. The substantivalist will say, yes, space-time is an object in its own right. Potentially it could have existed independently of any of its contents. And the distance relations between, say, material objects are mediated. This is a term, again, from Graham Nerlich. They're mediated by space-time points. So in order for there to be distance relations between objects, you need a further set of objects in the form of space-time points. The dotted arrow is supposed to convey that idea. So in opposition to substantivalism, we have relationism. It says, no, space-time does not exist independently of its content. It's not an object in its own right. It's a rather abstract way of referring to the network of space-time relations that there are between things or events. And space-time distance relations are unmediated. So one material object can stand in a certain spatial distance relation to another material object directly. You don't need a third object to mediate that kind of relation. Relationism, in the case of time, is often associated with the idea that there can't be time without change. Time must be filled with events. I think that would be one version of relationism, possibly the most familiar version. But since we're talking about unmediated spatial distance relations, it's just worth considering the possibility of unmediated temporal relations. So you could have events which are separated in time with no events between them, and yet not being exactly next to each other. That's just a detail, and it's not one that's going to matter for the discussion we're about to have. So I want to get on to a very famous and, of course, very familiar correspondence between two giants, one the Greek German philosopher and mathematician Gottfried Leibniz, and the English cleric Samuel Clarke. You'll see there's quite a difference in age between them, and they were having this correspondence very late on in Leibniz's life. In fact, the last year or two of Leibniz's life, so the correspondence is actually incomplete. Now, Clarke was a Newtonian in the sense that he accepted Newton's idea of space and time as being independent of their contents. And one of the themes of the correspondence is precisely this debate between relationism and absolutism, or substantivalism, as it's come to be described. So we're going to focus on a couple of arguments from Leibniz, to which Clarke did have a response, although we won't actually go into that this afternoon. And I'm going to call them detachment arguments for reasons I will explain in a moment. So the beige rectangle on your screen is supposed to represent absolute or substantival space as it is. And then the box with a picture of galaxies in is supposed to be representing the universe. So you can see there's quite a bit of what we might call extra cosmic space here, space that isn't occupied, which is necessary for the argument that's going to unfold. So we could imagine the universe occupying a particular position in substantival space. There it is, but it could equally have been in a different position. Just imagine the whole universe shifted to the to the west by a certain distance. Or if it stays roughly in its same position, maybe it could have been oriented differently in the same space. We just sort of flipped it upside down. So Leibniz's point here is that if you're looking at it from God's point of view, is there a reason to create one of these worlds over the other? Now, in each of these cases, the world itself, the universe, rather, consisting of these material objects, it's pretty much the same in each, well, it is exactly the same in each of these scenarios. The relative distance relations between objects in the universe are unchanged. What is different is the relation of these objects to absolute space itself. Now, God, says Leibniz, does nothing without a good reason. What reason could he possibly have had for creating that universe over that universe over that universe? Answer, nothing at all. There's really nothing significant distinguishing these. So we've got different possibilities here. In fact, we've got an infinite number of possibilities which are generated by absolutism or substantivalism, which turn out to be something of a theological embarrassment. It looks as though whichever universe or arrangement between the universe and space God brings into being, that decision was arbitrary. So that's a kind of theological take on Leibniz's principle of sufficient reason. There's got to be a reason why things are as they are and not otherwise. Let's now consider the case of time. So here's the temporal, the Leibnizian temporal detachment argument. So here we have the red arrow is indicating time, and here we have the universe. And we'll just assume that the universe had a beginning in time. We could suppose it to have had, as a possibility, a different beginning in time. It could have started later. So what we've imagined here is what you might call temporally shifted worlds. Same universe represented in two different possible worlds as starting at a different moment in time. Again, the temporal relations, the relative temporal relations between the different events that constitutes the history of the universe is absolutely constant between these two scenarios, between these two possible worlds. So where is God, or rather when is God going to create, to bring the universe into existence at this point in time, or at that point in time, or some intermediate point in time? Again, there doesn't seem to be any good reason. So again, substantivalism is giving rise to differences without really a significant or a distinction without a difference, as it were. Whatever God decides, it's going to be arbitrary. Again, a violation of the principle of sufficient reason. So these are, as I've said, detachment arguments, and it'd be helpful, I think, to have a sense of what a detachment argument is. So a detachment argument, as I'm using the phrase, is one that has the following form. Two situations or possible worlds are imagined in which the spatiotemporal relations between the contents of those worlds, material objects or events, is exactly the same, but the relations to absolute space-time are different. So what we're detaching here is the relative space-time relations between the objects, and on the one hand, and their relation to substantival space and time. You could have a difference in one without a difference in the other. And part of the moral of detachment arguments is an epistemological one. We could not detect the difference between these. It doesn't really matter how the universe is oriented. in substantival space or when it begins in substantival time makes no difference to anything we can observe. But there's also a metaphysical moral. And I think this is where we have the violation of the principle of sufficient reason. There would be no causal explanation of, or indeed causal consequences of, this difference between the worlds. And actually the epistemological moral follows from the metaphysical one. Because if there are no causal consequences of the difference, then we can't detect it, because our detecting it would be such a causal consequence. The overall moral is that absolute substantival space-time is completely redundant. It's explanatory redundant, and we're better off without it, which is precisely Leibniz's conclusion. If you're a relationist about space and time, these different thought experiments are not detecting, are not describing genuinely different possibilities. Okay, now here's our little interlude where I want to discuss what looks like a kind of related argument. And this is from Henri Poincaré's essay, The Relativity of Space. Suppose, he says, that in one night, all the dimensions of the universe become 1,000 times larger. The world will remain similar to itself if we give the word similitude the meaning it has in the is it the axioms of Euclid? Sorry, but part of the screen is hidden from me here. In other words, the spatial relation, the relative dimensions of things remains the same. Only what was formerly a meter long will now measure a kilometer, and what was a millimeter long will become a meter. The bed in which I went to sleep and my body itself will have grown in the same proportion. When I awake in the morning, what will be my feeling in the face of this astonishing transformation? Well, I shall not notice anything at all. The most exact measures will be incapable of revealing anything of this tremendous change. Since the yard measures, we seem to have gone imperial here, since the yard measures I employ will have varied in exactly the same proportions as the objects I shall attempt to measure. In fact, the change only exists for those who argue as if space were absolute. If I have argued for a moment as they do, it was only in order to make it clearer that their view implies a contradiction. There's been a change and there hasn't been a change. It would be better to say that as space is relative, nothing at all has happened. And it is for that reason that we have noticed nothing. That seems very Leibnizian in spirit. And it's making the same point that absolute or substantival space seems to be playing absolutely no explanatory role here, that it's offering us a possibility of something happening which we could not possibly detect. So, but in reality, there are no such possibilities because space is relational. It's not clear to me that this, well, in fact, I would say that this is, although it is kind of Leibnizian, it's not actually, strictly speaking, a detachment argument. In other words, unlike in Leibniz's thought experiments, we've not kept the relative distance relations between things the same, but shifted their position with respect to space and time in itself, because here we've actually got a change in those distance relations. So we're assuming here a kind of objectivism about metric. There is a fact of the matter as to how much bigger things are now than they were before. Now, just while we're talking about Poincaré, we might wonder whether this, whether he's right that we would not notice anything at all. So let's take the example of a cube. And let's imagine that the edges of this cube have doubled. Well, if the edges of the cube have doubled, has the surface area doubled? No, that's quadrupled. What's happened to the volume? Well, that's increased eightfold. So when Poincaré says all the dimensions of the universe become 1,000 times larger, it doesn't seem that that's actually possible. We might increase the dimensions in one dimension by that amount, but in two dimensions, when we're talking about area, we will have encountered a greater change, and an even greater one with respect to volume. That really ought to make a difference to the way things behave, how rapidly they cool down, for example, or heat up. If we can't detect those sorts of changes, it looks as though what Poincaré is imagining a sort of difference to things like clocks as well. Now you could say, well, look, you're presupposing, as we just said before, objectivism about metric, that there's a particular answer, that there's a fact of the matter as to how much things have increased. But that's, of course, built into the thought experiment itself. And it'd be a natural assumption for the absolutist about space to make. Poincaré himself can't assume conventionalism about metric from the start. That is, he can't say, look, how big things are is always relative to some conventionally chosen standard, because then it would immediately follow from that assumption that the doubling would actually not be a genuine possibility, because you're keeping relative distances the same. So it would not be dialectically appropriate for Poincaré could just make this assumption about conventionalism about metric. Okay, back now, interlude over, back to Leibniz. So let's just look at this question that Graham Nerlich raises about whether it made a difference that Leibniz was assuming that space was Euclidean in his detachment arguments, that space is flat, so that shifting the universe to a different part of absolute space or reorient it would have no detectable consequences. And Nerlich's conclusion is, well, yes, I mean, that is important. We can hardly blame Leibniz for making this assumption of Euclidean space. There were no other possibilities on the table at that stage. But when you introduce the idea of non-Euclidean space, I think Euclidean has been misspelled actually in that little picture there. Anyway, then changes in orientation, or indeed changes in size, thinking again of Poincaré's thought experiment, could potentially have effects. So consider a triangle, for example, in Euclidean space, all its internal angles add up to 180. In elliptical space, like the sort of surface of a sphere, they're going to add up to more than that. In a hyperbolic space with negative curvature, they're going to add up to less than 180 degrees. If you imagine a space with variable curvature and things moving through that space, even if everything keeps its relative spatial, roughly its relative spatial positions, there's going to be some sort of distortion here. So in non-Euclidean space, arguably, it's going to make a difference where things are in absolute space. Nevertheless, it remains true that in Euclidean possible worlds, orientation doesn't seem to be making a detectable, a causal difference. Okay. So finally, I want to come to the connection, and I hope this is the bit that will be less familiar to you. I want to make a connection between detachment arguments and determinism. So we need to have a definition of determinism available. Here it is. I mean, there's more than one way of defining determinism. This particular way of defining it makes it time symmetric. In other words, I've not distinguished here between sort of past and future. So we'll say that the world, W, is deterministic if and only if for any time t, any physically possible world which is in the same state as W at t is also in the same state at any time earlier or later than t. So if you look at the diagram here, so the upper diagram represents physically possible worlds. These are worlds, incidentally, that share the same physical laws. These are two worlds which coincide in the earlier part of their history, but diverge thereafter. This would be ruled out by the determinism that we have just defined. If they're in exactly the same state at one particular time, then they're going to be at the same state in later times. The bottom diagram represents two worlds which coincide at later times, but not at early times. Again, this would be ruled out by time symmetric determinism. So that's the sense of determinism that I'm going to be working with. So back to Leibniz again and the thought experiment by which God creates the universe at a different point in absolute time. These are what we called time-shifted worlds. So these are two possible worlds. What is going on in these worlds in terms of the events that are taking place are exactly parallel. I've chosen to sort of represent the history of the universe here, starting with the Big Bang and ending with the Big Crunch. There's a certain sort of symmetry here. Now, these two worlds, they're physically possible worlds, they coincide at certain moments in time, but you can see they do overall have a different history, precisely because they are time shifted. The relative positions of events, the relative times of events are the same in both cases, but they're happening at different absolute times. So we've got, as Leibniz would say, a violation of the principle of sufficient reason. Another way of putting it is that you've got a violation of determinism. Possible worlds that coincide at certain points in time, but not at others. Just look again at our definition of determinism. The world W is deterministic if and only if at any time t, any physically possible world which is in the same state as W at t is also in the same state at any time earlier or later than t. And focus on the t's here, the things that stand for times. The question I want to ask is whether the times here are relational or substantival times. How are they going to be defined here? Are they defined in terms of the kinds of states of affairs that are instantiated together, or are they bringing over times which are quite independent of those states of affairs or events? And this gives rise, depending on how we answer the question, this gives rise to two kinds of determinism. And I'm going to describe this as the difference between type determinism and token determinism. So type determinism we can associate with determinism that's defined according to relational times. So a world state determines what kinds of world states get instantiated earlier or later than that state. Token determinism, in contrast, is a world state that determines what token world states, what particular world states exist earlier and later than that state. Okay? So one might say that temporal and spatial detachment, where we're keeping constant relative positions in space and time, but varying relations between objects and events on the one hand and absolute space and time on the other, is a failure of token determinism, not type determinism. So if we just go back to our picture, we've got exactly the same states of affairs being instantiated. They're instantiated in the same temporal order, but the token times, the token substantival times at which these types are being instantiated are different. So the difference between these time shifted worlds is a difference in tokens rather than others, and it represents a failure of token determinism, I would say. But is token determinism intelligible? I would say not, or at least even if it is, it's not clearly a kind of determinism that we should care about. We can readily imagine how a cause could determine what kinds of things, what kinds of states will be instantiated. So the heating of a bar of metal will cause the type expansion to be instantiated, but it's not going to determine what tokens will constitute the effect. Maybe God can do this. Maybe God can bring about that one token is instantiated rather than another. Tokens sort of exist ideas in God's mind, and God can realize one rather than another. So Leibniz, this lets Leibniz off the hook. Maybe Leibniz can appeal to some sort of violation of token determinism as a sort of a bad thing, theologically speaking. If we don't bring God into the picture and we're just relying on causation, it's not clear that we can actually make sense of token causation. And so we should not care about a violation of token causation. So in conclusion, I've suggested that detachment arguments appear to appeal to a certain kind of determinism, what I've called token determinism, where states of affairs determine what tokens will instantiate what types, not simply what types get instantiated. But there's no reason to accept that kind of determinism. The kind of determinism worth caring about is type determinism. Substantivalism does not oblige us to reformulate determinism. It does not oblige us to talk in terms of token determinism as well as type determinism. And that is the conclusion of the paper. Thank you so much for listening. Thank you.
Thank you very much for your presentation. I now want people who want to, okay, Giuliano raised the hand. Giuliano?
Sorry, can you hear me?
Yes,
Yeah.
I can hear you, yes.
Okay, perfect. Yeah, thanks for the talk. So could you just say a bit more how exactly the issue with respect to the non-failure of token determinism is related to the point of the failure of the principle of sufficient reason? Because one might think that the two things may also come apart. No, so I can think of someone thinking that so even if there is no failure of token determinism, there are still facts like the relation of distance between the Big Bang and a random point of a substantive space-time before the Big Bang, and you know, it might be that this relation could be being longer and nothing seems to change, and this seems good enough for the principle of sufficient reason to fail, and so it still seems evidence against the substantivalist.
Yes, I mean, if we're assuming that the different parts or the different components of space and time are indistinguishable, and actually thinking about Euclidean geometry again, that might be an unsafe assumption, but just assuming that, it looks as though the relevant difference is going to be a difference between the tokens, which tokens get to stand in these relations to the universe as a whole. And there's nothing to explain why it's these tokens that are standing in that relation rather than, say, these later tokens, or these later token times. But the states of affairs that get instantiated will nevertheless be exactly the same. So that's why I was sort of associating a failure principle of sufficient reason in that case with a failure of token determinism, because that seems to be the relevant difference, not a type difference, but a token difference.
Okay, I think I see better what you meant now. Okay, thanks. I'll let the other ask, and then maybe I come back on this. Thanks.
Okay.
Federico?
Yeah. Can you hear me? Okay.
Yes, I can. Yeah.
Thanks a lot for the talk. I wanted to ask you something about about the temporal argument, the temporal detachment argument of the substantivalist. I was wondering about the case in which we have an infinity of time before the supposed beginning of the universe. So in that case, I think the two different configurations, so two different position of the universe in the temporal line would be difficult to differentiate, because the infinity of you will always have a one-to-one correspondence of all the instants before the beginning of the universe. So I was just wondering why, if this will make it, because usually the problem comes in causal explaining why the universe began at a moment rather than another. But it seemed to me that you were rather pointing at explaining the difference between, two different position of the universe in space and time. So I was wondering if you also see this difference. And
sorry, could you have another running, because I'm not quite seeing the question here. Sorry about that.
So if you have the universe beginning at a certain moment in time,
yeah,
and you have an infinity of time before that,
yes,
then you always have, independently on where you make the universe begin, you have
yes,
all the past infinity of time before the universe. You can put all the instants.
Okay.
One-to-one correspondence.
Yeah. So exactly what is the difference? Yeah.
Exactly what is the difference in that case?
Right. Okay.
Because
yeah. No. Sorry.
Put the question in terms of why the universe began at one moment rather than another, then maybe you can ask for a causal explanation of the beginning of the universe at that particular moment. But if you're looking for an explanation of two different of the two different relation between the universe and the absolute space-time, I don't know if I'm putting it right, then it seems to me a different question. So I was wondering if you agree.
Right. Okay. Well, I think, I mean, if you assume a sort of infinity of time before the beginning of the universe, so the question is, can we then make sense of time-shifted worlds? Because in both cases, we've got an infinity of time before the beginning of the universe. And I think this kind of reinforces my point that we're dealing with a failure token determinism here, because the one thing that makes the difference between the universe is which particular times occur at the, or which particular time, which particular substantival time coincides with the beginning of the universe. Everything else you can say about the worlds looks as though it's exactly the same. The only difference is which token times instantiate the states in question. And what I'm suggesting is that it's improper to ask for any kind of explanation of that. You know, why this token rather than that token? That's not something that we would expect to explain, e.g. causally.
Okay. Okay, thanks.
Carl?
Hi. It's nice to finally kind of meet you virtually. I've known
Yeah,
about
you too.
your work for many years. So I guess one quick question of clarification, and that's about why you're saying that your response to the temporal shifting argument on the basis of this distinction between type determinism and token determinism, why that also takes care of Leibniz's shift arguments, spatial shift.
Right, yes, I didn't say anything about that. But I think it's kind of structurally similar. Again, assuming infinite absolute space, everything you want to say about one world where the universe is in this particular position in absolute space and is going to be the same as everything you want to say about this world where it's in a different position with respect to absolute space. Again, in terms of the kinds of properties that get instantiated and the relations those instantiations stand to each other, the only difference being which token regions of space instantiate those states of affairs. That doesn't seem to be determined. There's nothing we can appeal to in each world which determines that the universe is in this particular position in absolute space rather than that particular position, precisely because the difference is only a difference between tokens. There's no type difference. So that's the way the argument would run in that particular case.
Right. I mean, I totally agree with the position you're recommending, and it's I mean, I think also that one shouldn't distinguish universes on this kind of token basis, which really this is the point of the debate about John Ehrman's whole argument.
Yes,
it's really the same point, and I was on the side of people saying, look, you can be a substantivalist if you want, and say that all these worlds, these so-called shifted worlds, really are the same possibility.
Yeah.
Because there's no need to ascribe the kind of identity to space points, and time points, or space-time points that is presupposed by the distinction between these, the alleged distinction between these worlds that we're talking about. And so, I completely, I'm completely in sympathy with what you're saying. Although I think that Leibniz can still go against Newton and Clarke with his velocity shift arguments.
Okay. Yeah, absolutely. Yeah, no, I mean, this is a very limited defense of substantivalism against a particular kind of attack. It looks as though it's appealing to a principle that ultimately is not one we want to accept. But of course, that's not the end of the matter by any means. There are other kinds of case where we might where we want to attack the substantivalist. I agree with that. I'm glad you mentioned the whole argument, by the way. I didn't dare raise it in my original. Sylvia, you may remember when I first sent you my idea for the paper, I in a fit of hubris, indicated that I might be discussing the whole argument, and whether that was also subject to the same kinds of objections. And then I started looking in more detail at the whole argument and decided that I just didn't have the courage to embark on that. But it would be, I would really value people's views on whether they think the kind of determinism that is under threat in Ehrman's whole argument is this kind of token determinism rather than a type determinism. In other words, it's a kind of determinism that we shouldn't actually be worried about. But you know, the details of the argument were sufficiently daunting for me to be able to not to be able to kind of work out that consequence. So you know, a more informed opinion is what I could do with at the moment. And it sounded to me, Carl, as though you were endorsing that, perhaps.
Absolutely, yeah.
Yeah, that's great. That gives me hope. That gives me hope.
Okay, so I cannot see other hands raised. So I think that Giuliano wanted to ask something more, if I'm correct.
Yeah, we will get to ask, I mean, it's sort of a curiosity, but so about the Poincaré point.
Oh, yeah.
So I was wondering, I mean, that's actually what I'm saying. I think it goes in the direction that you want to go. So probably it's not really a question or but. So I was wondering if someone anyway. So let's say that someone insists on the fact that you know, property like the behavior of the cube with respect to eating or things like that will remain the same because you know, the internal constitution also will change. I don't know. No, maybe you know the speed eating just depends on the number of molecules and their relative position and relative velocity, and that remains the same. So the eating up is also the same. I don't know. I mean, let's say that once someone fixed this somehow.
Yeah.
I was wondering, there's still the case that if space-time is not Euclidean, but it is not just curved, but also connected in a sort of weird way. So if there are things like wormholes, you know, we could still, you know, compare things how they are at different times, and so we could realize that the expansion happened. So there is like well, that's a science fiction story, but it's a nice one. So it's a short story written in the 40s. It's called Time Locker, and basically there is someone who opens a locker and gets almost killed by a huge ant that comes out of the locker. And so an investigation starts, and then basically they discover that it's the person himself that the day after you know, open the locker and see a small person and try to grab it. And the explanation is that because the universe is expanding and this is in the locker there is a wormhole. So and actually after that, you know, in the story, you know, they discover that there is this function of the so that things are actually growing bigger, you know. And that's actually a point that, I mean, this is a short story, but I mean, it proves that actually if there is a weird connection between space-time, that kind of modification will be detectable.
Well, absolutely, yes. I mean, in a non-Euclidean space, the you know, the doubling thought experiment is certainly, or increased by 1,000 times. That's certainly going to make a difference to, you know, relative relations as well. So that's why I wanted to suggest that Poincaré's thought experiment isn't a detachment argument. I think, you know, maybe one of the best arguments in favour of substantivalism is precisely the kind of explanatory value that these sort of non-standard topologies would have. You know, the way things behave in space-time depends on the geometrical structure space-time. Maybe it is weirdly connected in certain ways. Maybe it's kind of non-orientable. So your left hand could turn into a right hand simply by moving around in a certain kind of position in space.
There is a Möbius stripe topology, right?
Yeah, absolutely, absolutely. You mentioned that story. There's an older story by H.G. Wells. You're probably familiar with it. I forget the name of it now, but it's someone who involved an explosion in a chemical laboratory that transports to another dimension and it's sort of reoriented. That's right. Yeah, absolutely. Left, right, reversed.
Yeah, exactly.
Which certainly could have some pretty serious consequences. So yeah, I mean, I think substantival space is potentially can explain all sorts of things in the way that Graham Nerlich has pointed out. I suppose the point about detachment arguments is that they are they're intended to be kind of immune from that kind of approach, because it's just built into the arguments that the relative positions of things remains unchanged.
Right. Yeah.
So you can say, you know, we're sort of confining this to sort of perhaps a you know, Euclidean worlds or whatever.
Yeah. Well,
yeah.
Is the same. Yeah.
Mm.
So, Carl?
Yeah, I think I may have missed something when you were talking about Poincaré's argument, and then you brought in the curved spacetimes. Because did you say that the Poincaré story won't work in those kinds of spacetimes?
Oh, not necessarily. It depends. I think. I mean, I hope I'm slightly out of my comfort zone here, but I think it probably depends whether the curve, if you're dealing with a curved space, whether that curvature is uniform or not.
Right.
So I'm guessing that in a kind of space that's sort of represented by the two-dimensional surface of a sphere, let's say doubling the size of a triangle is not actually going to have an effect on the internal angles. But if you're doubling in a kind of variably curved space, potentially it could.
Well, actually, what I was thinking is that when you consider all the relations, all the spatial relations between existing things, then no change in size goes unpunished in the curved, in the spherical geometry. But in the hyperbolic geometry, you can do it as much as you want, because because then the relative sizes of the relations will remain. But so if you think about a triangle on the surface of a sphere, the two, say, just take two vertices of the triangle, and you think, okay, they have a certain distance relation from each other, but they have another distance relation, which involves going around the opposite side, as it were.
Of course.
That's as soon as you expand,
then
that one shrinks.
It will, of course, it will. Thank you for that. Yeah, the pen is now dropped.
If I may add also that to think in terms of spherical geometry, Leibniz argument is, I mean, for example, Kant criticized Leibniz arguments precisely saying that two triangles can be differently oriented if I think of them on a spherical surface. So in terms of spherical geometry, then I have different orientations of two. I mean, I can take two triangles, you know, with the same dimension and so on and so forth, but still, if I put them on a spherical surface, then they can have different orientations, and I can distinguish them.
Right.
They are not identical to each other.
Yeah.
So it's very interesting, this.
That's right. So if the sort of indiscernibility between these different orientations, one might say, well, that's contingent on the structure of space, and not there's not necessarily indiscernibility in the way that Leibniz supposed. Yeah.
I think I want to object there.
Okay.
To what Sylvia said. Because this raises another old argument by John Ehrman, where he used incongruent
Wait a second.
counterpoints.
It's not me. It's Kant. It's Immanuel Kant.
Okay. Blame Kant. Yeah.
Yeah, no, but it was a very clever and nice argument in favor of Newtonian space by Kant, back when he was a Newtonian. And then he tried to turn the argument into one for the ideality of space. But
yes, yeah.
But if you're a Leibnizian, you think that you take a world and then, as it were, do a mirror image transformation of the whole world. You haven't done anything, and you just have to stick to your guns on that. So but what's real is if you have two different non-equilateral triangles, scalene triangles that have the sort of same sides, same sizes of sides. There's two different orientations they can have on a sphere. So there's an intrinsic difference between a spherical world where we have these two triangles and they're mirror images of each other versus if they're similar to each other. But that's the end of the story for a Leibnizian. So they just want to say then there's not a difference between a world with just the one triangle and another world with just one triangle, but with the opposite orientation. That's a mistake for a Leibnizian.
Yeah, absolutely. Yeah, it's weird the way that mirror image shapes just played such a completely different role for Kant at different times, as you said. In that early essay on space, an argument for substantivalism, and then later on, the same kinds of problem, an argument for idealism about space. The fact that we can conceive of the difference, which isn't a physical difference, suggests that the difference is in our minds. Yeah.
Are there questions, comments? No? Okay, so let's thank our speaker again. And actually today is exactly 1 year. So we had our last in presence lecture 1 year ago. So anyway, it's a pleasure to continue, even if it's online, our seminars. So thank you all for being here today, and thank you, Robin, very much again for this presentation. Thank you all.
Thank you.
See you. Bye bye.
It's been a pleasure. Thank you all very much for your comments and kind attention.
Thank
it's been
you.
a real pleasure. Thank you.
Bye.
Bye.
Thank you.